All right, so here we are at 4.4e, principal and interest, example 2. Essentially, it's going to be the same type of idea. We have to look at same type of idea as example 1. We've got to look at each investment as a column, look at a total for the column, and then one row is going to be principal, one row is going to be interest, just like, let's see, that one here. So again, here's our definitions. Interest, principal, rate, and time. R rate has to be in a decimal form. So if you have 5%, it's got to be R as 0.05. But here we set up our column here of 3.5, 2.5% column, and total, and then principal here and interest here. So let's go here. Let's use that same idea and remember that here's our formula. Interest equals principal times rate times time. We'll use that in the interest column or interest row. So here's our question. Addie has a total of $8,000 in two accounts. There's our principal. One pays 5% interest. The other pays 6.5% interest at the end of 1 year. 1 year. There's our T. She earned $475 in interest. So there's our total interest. Use a system of equations to determine the amount of invested in each account. All right, so like I said, for this one, straightforward enough to say, let's see, if I'm going to set it up, I'm going to set it up with, let's see, a 5% interest account here and a 6.5% interest account here and a total column. So there's my three columns. And here is number 1, my principal. Number 2, my interest row. So what do we know? What information do we have? We've got total, let's see. So we set that one up. Yeah, let's see, we set that one up. $475 in interest goes total interest, $475. Let's see. Oh yeah, total of $8,000 in two accounts, 8,000. Oops, sorry, hang on a second. Yep, that's right. 8,000 goes here. And I'm sorry, 475 should be in red, so let me see if I can write over that, 475, just to make it a little clearer. All right, so what do we have? We know we've got to define our variables. So we've got to define, well, let's see, define x equals amount of principal in 5% account, y equals amount of principal in 6.5% account. So let's go up and fill in those numbers. X is here, y is right there. And now after that, we just take our interest equals principal times rate times time, that equation here, to figure out our interest. What's our principal? X. And you know what? Let's write this down as it stands. Interest equals principal times rate times time. Principal times R times T. Principal is, I'm going to write it up here and see if I can scrunch it in here. Principal is X. Rate R is 0.05. And our time is 1. So this made a little more mathy would be 0.05x. All right. So that by the same idea, we can write it out kind of according to the formula, or we can just say, you know what? I know that it's let's see, the time is 1 year, so that kind of goes away. And principal times rate is really rate times principal, which is 0.065y. And now I can set up my two systems, or my system of equations, using x plus y equals 8,000, because x amount in 5% plus y amount in 6.5% gives me a total of 8,000. And by the same token, we use red to say 0.05x plus 0.065y equals 475. So now we've got our system of equations right there. And what I would do, I guess, first would be to multiply this red one by 1,000, to get rid of the decimals. because here is a 0.05x. We multiply by 1,000. That one goes to whole numbers. This one goes to whole numbers. This one goes to a bigger whole number. Just like the previous one, the green one stays the same. So I'm going to rewrite the green one as x plus y equals 8,000. And normally I would continue this on over here, but I don't have a whole lot of space. So I'm going to have to continue it down here. In red, if we're multiplying by 1,000, I would multiply this by 1,000, move the decimal point 3 spots. So I would get 50x plus 65y equals 475 times 1,000, 475,000. And there's our system of equations. And essentially, what we do here is probably multiply, let's see, multiply the green. Now, we've got the same system of equations, just the red has been modified. And now we multiply the green one probably by, let's say, negative 50. To give us negative 50x minus 50y equals, let's see, 4, 0, and 1, 2, 3, 4, 4 zeros plus 40. Yes. So there's our equation. The red equation is, positive 50x plus 65y equals 475,000. Now we're using the addition method, or elimination method, it's also called, to eliminate this variable. Now we add up the green and the red, and we say negative 50y plus 65y gives me 15y equals 75,000. That's a 0. Divide by 15, and I get y equals 75 divided by 15 is 5, and 3 zeros. So there's my first variable, y equals 5,000. And don't stop here, because again, we've got a system of equations, 2 unknowns. We've got to solve also for x. If we go up to the green equation, we'd substitute y in as 5,000 and get x equals 3,000. And that would be our system of equations, our solution of system of equations. I would, if I were you, go back and double check to make sure that that 3,000 and 5,000 works in your second red equation, just to make sure. But for expediency purposes here, I'm going to say you can double check and we'll go from there.